If you remember from lesson 1-5, we went over absolute value and we reviewed exactly what the absolute value was. Here I'm going to talk about the absolute value within inequalities, and then we're going to go over something called compound inequalities. So the first thing we're going to look at is if the absolute value of A is greater than B. If the absolute value of A is greater than B, then A is greater than B, or A is less than negative B. Let's take a look at an example of that. Let's say that we have the absolute value of A is greater than 2/3. So the absolute value of A is greater than 2/3. That means if 2/3 is B, then A is greater than 2/3, so we'll mark 2/3, or A is less than negative B. Negative 2/3, we'll mark that. And you can see A is greater than B, so we're going to shade everything to the right of 2/3. A is less than negative B. We're going to shade everything to the left of negative 2/3. Let's think about this before you just go along with it. Let's say that A is 1. The absolute value of 1 would be equal to 1. And 1, yes, is greater than 2/3. Let's look at negative 1. The absolute value of negative 1 is a positive 1. Remember, because it's the distance from 0. And that, again, is greater than 2/3. Let's look at 0. The absolute value of 0 is 0. And 0 is not greater than 2/3. 0 is actually less than 2/3. So you can see, let me go ahead and change up the color, that we shaded in everything to the right of positive 2/3 and everything to the left of negative 2/3, and this middle region from negative 2/3 to positive 2/3 is not shaded in. And I realized actually that this is a greater than sign, so really we should be drawing an open circle around the 2/3 because the 2/3 is not included. If it was a greater than or equal to sign, we could shade in that 2/3. So let's look at another absolute value inequality. If the absolute value of A is less than B, then negative B is less than A, which is less than B. Let's look at an example of this. Let's say that the absolute value of A is less than 2. And for this case, let's go ahead and use less than or equal to 2. Go ahead and draw out the number line. Since in this case, B is 2, negative 2 is less than A, which is less than a positive 2. So now we're shading in this middle region. And why is that? Let's take a look at a few numbers. Let's say we use a negative 3. If A is negative 3, the absolute value of negative 3 is equal to a positive 3. And 3 is not less than or equal to 2. So that would not belong in the shaded region. Let's look at a positive 1. The absolute value of 1 is equal to 1, as well as the absolute value of negative 1. and 1 is less than or equal to 2. Let's go ahead and look at 0 as well. The absolute value of 0 we know is 0, and 0 is less than or equal to 2. So when the absolute value is less than or equal to another value, we're going to shade in that middle region. When the absolute value is greater than or equal to another value, we're going to shade in past that middle region. And this takes us directly into compound inequalities. So compound inequalities are inequalities that are joined together with the words or, and. The word or is saying that at least one is true. So let's look at our first absolute value of inequality property. If the absolute value of A is greater than B, then A is greater than B, or A is less than negative B. That means at least one of those is true. If we had, let's say, the number -1. -1 is less than -2/3, but -1 is not greater than 2/3. So only one of these inequalities is true, and that's the second one. And is saying that both the inequalities are true. But this is a little confusing because the word and isn't in this second absolute value of inequalities property. But this inequality is technically two inequalities combined with and. When we say negative b is less than a, which is less than b, we're saying that negative b is less than a and a is less than b. So if we pick a number, say -1, we know that the absolute value of -1 is less than or equal to 2 because -2 is less than -1 and -1 is less than +2. So -1 falls within both inequalities. So both of these are true. Whereas above, when we had compound inequalities that were joined with or, only one of them could ever be true. Whereas here, both of the inequalities hold true for the numbers that we pick within that interval. So just remember that or, at least one of those inequalities is true, and both of the inequalities must be true. Let's take a look at an example of this.